For the next set of problems, we're solving equations, and do remember that solving an equation that has a single variable means finding the value or values of the variable that make the equation true. So in 125 we have an exponential equation, and one of the ways that we can solve an exponential equation is to give ourselves a common base. 4 is 2 squared, and 8 is 2 cubed. And now when we raise a power to a power, we multiply exponents, so the new exponent is 4x plus 2, and on the right side the new exponent is 3x minus 6. Now that we have a common base, we can just equate the exponents, and subtracting x from 3x from both sides, and then subtracting 2 from both sides, we get x is equal to negative 8. In 126 we have a logarithmic equation. Log base x of 1,000 is equal to 3, so we can rewrite this one in exponential form. Our base is x, a logarithm equals an exponent, so the exponent is 3, and that equals 1,000. We can solve by taking a cube root, so x is equal to the cube root of 1,000, and that means that x is equal to 10. In 127 we can rewrite in exponential form as well. Our base is 8, the logarithm equals an exponent, so 4/3 is the exponent, and that equals x. So in doing that, we've solved for x. We just need to simplify the solution. So 8 raised to the 4/3 power is equivalent to the cube root of 8 raised to the 4th power. So the cube root of 8 is 2, raised to the 4th power is 16, so x is equal to 16. In 128, we can re-express both sides using a common base. 3 raised to the 3rd power is 27, and 3 raised to the 2nd power is 9. And when we raise a power to a power, we multiply the exponents. And now that we have a common base, we can just equate the exponents. And so x minus 3 is equal to 4, and x is 7. In 129, log base x of 2 is equal to 3. We can rewrite in exponential form. Our base is x, and our exponent is 3, because a logarithm equals an exponent, and that's equal to 2. We can solve by taking a cube root on both sides, so x is equal to the cube root of 2. In 130, we can solve by rewriting in exponential form. Since this is an log with an unspecified base, then it is base 10, and so 10 is our base. And since a logarithm equals an exponent, -1 is equal to the exponent, and that equals x. We have only to simplify that result, and 10 to the -1 power is 1/10. In 131, rewriting in exponential form, our base is 4, exponent is 2 since a logarithm equals an exponent, and that equals 3x minus 2. 4 squared is 16, adding 2 to both sides, and dividing by 3, we get x is equal to 6. In 132, we have a logarithm with the same base equal to another logarithm with the same base. So in those cases, the arguments of the logarithm are equal, provided that our solution is within the domain of each of these functions. So we're going to check our solution at the end. Let's subtract x from both sides and add 1 and divide by 5, and we get x is equal to 4. And in those cases, when we do a check, that's going to be the natural log of 6 times 4 minus 1 is 23, equals to natural log of 4 plus 19 is also 23. Natural log of 23 equals natural log of 23. That checks, since both of those are real expressions. Okay, if we get a logarithm of 0 or a negative number, that's not defined. In 133, we can condense this logarithm, the two logarithms on the left side of the equation, by rewriting their subtraction as a single log of a division. So that's the log base 5 of x plus 1 divided by 3 is equal to 2. Now we can rewrite in exponential form. 5 squared is equal to x plus 1 divided by 3. Since 5 squared is 25, we can now multiply both sides by 3, and we get 75 is equal to x plus 1. So subtracting 1, x is 74. We do need to check our result here and just ensure that the argument of each logarithm in the original equation is positive. if x is equal to 74, and in that case it is, because 74 plus 1 is 75, which is a positive number. In 134, we have the natural log of e to the 5x plus 2 is equal to 30. There's a couple different ways we can approach this one. If you want to just put it in exponential form, you can. And since we have an ln, that's a base of e. It's a natural logarithm. So e is our base, 30 is our exponent, since a logarithm equals an exponent, and the result is e to the 5x plus 2. What we now have is an exponential equation with the same base. In those cases, if e to the 30 equals e to the 5x plus 2, then 5x plus 2 and 30 must be equal. And solving this equation, we have e is equal to 28/5. I'm sorry, x is equal to 28/5. Last equation in this section, if our base is 10, our exponent is 2, since a logarithm equals an exponent, and that equals x minus 3. Remember, log is, with an unspecified base, is base 10. So since 10 squared is 100, adding 3 to both sides, x is 103.